3.5 mixture problems. In this lesson, you will see that you are going to be doing lots of word problems that result in simultaneous equations. So the basic premise is that you're going to have one thing. Notice in my chart I say thing one, and you're going to have another thing, thing two, and then you're going to mix them up and you're going to make a mixture. Okay, so I recommend, no matter where you are at the beginning or the end, that you copy down this chart because this chart will work for pretty much every mixture problem. This is how it works, and I'll just explain it and then we'll apply it to a couple examples. Thing one, so if you were making trail mix and you were mixing nuts and chocolate chips, thing one would be the nuts, thing two would be the chocolate chips, the mixture would be the trail mix. So how much would be the first column. So what is my number or my amount of nuts? And you'd put that here. What is my number or amount of chocolate chips? What is the number or the amount of trail mix? Because it's not always going to be equal parts in a lot of things. The second column is the cost per unit or the value per unit. Well, that's kind of hard to understand right now, but you'll see how that works later. But basically, what's the cost for 1 gram of nut? What is the cost for 1 gram of chocolate chips? And then what's the cost of 1 gram of the trail mix? Say you're going to sell it. The total cost or the total value is computed by multiplying this column times this column equals the total cost or the total value of all those nuts in the pile. Okay, so copy that generic one down and now let's apply it to an example. Okay, here's our example. I have 29 coins, all nickels and dimes, totaling $2.15. How many nickels do I have? I have that generic chart written up here, so you can see this is the one that was on the page before. I've erased thing one and thing two. I probably could have erased mixture also. But basically, I'm thinking about I have a pile of coins, some nickels, some dimes, and it totals $2.15. Now, I could solve this problem using guess and check. The name of the course, though, is algebra, so we want to use our most efficient way to get there, which is using algebra. So thing one is nickels, and I'm only going to be able to fit the word nick in here, so nick, and dimes. So this row is representing nickels, this row is representing dimes, and this row is representing our mixture, which you can just write mixture, but I'm going to write coins. Okay, so how many nickels do I have? I don't know. I've got 29 coins, but I don't know how many nickels and I don't know how many dimes. So guess what? X, Y. And how many coins? 29. Okay, hopefully that seems understandable to you. What is the cost per unit or the value per unit of nickels? Well, basically, what is 1 nickel worth? Okay, 5 cents. And dimes, 10 cents. And coins, well, a pile of coins isn't going to have a value for 1 coin because it varies. So in this problem, this box does not work. It's not applicable. And a lot of times this box is not used. Sometimes it is, and you'll see in one of the examples I give later it is used, but in this case it's not. Okay, so the other way you could do this problem is you could not use a decimal. You could say nickels is worth 5 cents, dimes are worth 10 cents. And that would be okay not using the decimal. You just have to be careful in another situation, which I'll show you at the end or later on. Okay, now I haven't used my $2.15 yet, $2.15, but I am going to use the formula along the top. If I take my x and I multiply it by 0.05, I will get my total value in algebra form. And this one is 0.10 y. And if I used the red form, which is in cents, I'd have 5x and I'd have 10y. Now, what is the total value of my coins? Well, that's $2.15. So I'd write up here, actually in black, I'm going to write 2.15 to represent $2.15. And in red, I'm going to write 215 because 215 would be if I didn't use a decimal. And that's what you have to be careful about when you're doing this. Okay, so now remember I have 2 variables, so I need to have 2 equations in order to solve. I also want to know how many nickels I have, so I'm hoping to get x at the end. Remember, in jousting armadillos, you had to define your variable, write an equation, and solve. So here I've defined my variables. I'm going to write an equation, and then I'm going to solve it. Here's one equation, and here's the other equation. And let me show you how to write it. Let's extend a little more. It's a little too far. Okay, so my first equation, if I follow the black, is going to be x plus y equals 29, because that's my total coins. My second equation is found right here. 0.05x plus 0.10y equals 2.15. So 2 equations, 2 unknowns, and now I can use substitution or elimination to solve it. My personal favorite happens to be the red form, just because I think it's a little easier to work with. X plus y equals 29, and 5x plus 10y equals 215. In order to solve it, I'm going to choose to use elimination. So I'm going to multiply this whole equation by -5, and I get -5x minus 5y equals -145. Okay, now I'm going to put those two together. 29 times 5. I just want to check my math. Yep, I'm good. So if I go ahead and put these together, this eliminates and I get 5y equals 70. And then if I divide by 5, I'm going to have y equals 14. Okay, well, have I answered my question yet? I've solved the problem, but I always need to go back and see. How many nickels do I have is the question. So nickels, remember, was x, and I have solved for y. So I need to figure out what x is so I can answer the question. So I knew my first equation was x plus y equals 29. So if I have x plus 14 equals 29, I basically am going to use subtraction to figure out what that is, and I get 15, x equals 15 times, or excuse me, 15 nickels. So then don't forget, you should write your answer in a complete sentence. I have 15 nickels, and I have completely solved this problem. So let's move on to another example. You will find this one exactly in Linus's book. I don't know what number it is, but this is exactly from the problem set. So I don't have my equation, but the equation will never change on the top. Okay, I have to figure out what two things I'm talking about, the mixture of thing 1 and thing 2 as well. Okay, so let's read it. Your magician master gives you a crate containing both three-winged and 5-winged mice. There are 28 animals and 98 wings. How many of each variety of mouse has he given you? So what are the two things I'm talking about? Well, okay, 3-winged mice and 5-winged mice. So 3-winged mice, 5-winged mice. And then I think I'm going to say the mixture here is just going to be basically of all these kinds of mice. So let's call them animals. Okay, so your magician master gives you a crate containing both 3-winged and 5-winged mice. There are 28 animals. Okay, 28 animals and 98 wings. Oh, I don't know what to do with that yet. But I don't know how many of this, and I don't know how many of this. So I know my first one is that I've got X amount of 3-winged mice, I've got Y amount of 5-winged mice, and I have 28 animals total. I even know that that's my first equation. Okay, now let's go to the next column. Cost per unit or value per unit. Well, that doesn't even make sense. But if I were talking about per mouse, basically here I'm talking about wings per mouse. So on the first type of mouse, how many wings are there? 3. On the second kind of mouse, how many wings are there? 5. And again, this is not going to make much sense because I basically just have a pile of 2 kinds of mice. I can't put them into one animal. Okay, now I'm going to use the equation. I'm going to multiply this column times this column, and I'm going to get 3x this column times this column, and I'm going to get 5y. And here, total cost or total value. Well, it's not going to be total cost or total value. It's going to be total wings. So the total wings of all my animals, it's right here. There are 28 animals and 98 wings. So there we go. So my other equation is going to be 3x plus 5y equals 98. And now I need to solve. So I think I'm going to multiply this whole equation by -3, and I'll get -3x minus 3y equals 28 times 3, which is 84, -84. 2y equals 98 minus 84 would give me 14. And I have y equals 7. So I have 7 5-winged mice. How many 3-winged mice would I have then? Basically 21, because they have to add up to give me 28. If I go back up to what it was asking me, it says, how many of each variety of mouse has he given you? Okay, and now I can answer the question. 21 3-winged mice and 7 5-winged mice. Done. Okay, one more example. I know this is long, but this can be tricky. 16 pounds of brand M cinnamon was made by combining 12 pounds of Indonesian cinnamon, which costs $19 per pound, with 4 pounds of Thai cinnamon, which costs $11 per pound. Find the cost per pound of the mixture. Okay, brand M is the mixture, so I'm going to write brand M here. And we're mixing Indonesian and Thai cinnamon. Okay, so I know I have 16 pounds of brand M. I know I have 12 pounds of Indonesian. I know I have 4 pounds of Thai. Well, look at that. That equation is already complete. 12 plus 4 does equal 16. No unknowns, though. Okay, so Indonesian, let's take that circle away. The Indonesian, we said, is $19 per pound. This one is $11 per pound. Find the cost per pound of the mixture. In fact, this is what I'm trying to find out this time. So I will be using this box, okay? Now, remember the formula on the top? Because the only other information I've got, in fact, I haven't gotten any other information. So now I'm going to just have to use the chart. So I multiply 12 times 19 to give me the final box. So 12 times 19, I'm going to use my calculator for that, and I get 228 is how much the Indonesian cinnamon costs. And then I'm going to do 4 times 11, which is $44, is how much the Thai cinnamon costs. And then, based on what I've done on my other examples, I know I can add these together to get 272 is how much brand M is going to cost in total. So I can use my formula to write an equation. And look at that. I only have one unknown. So I only have one equation, because that's all I need. One equation, one unknown. Two unknowns, 2 equations. 3 unknowns, 3 equations. So if I solve this, I get 17, which means that the cost of the mixture, cost per pound of the mixture, is $17 per pound. Okay, that was a little redundant how I wrote it, but it does answer the question. Okay, good luck.